Can we ask questions?
Of course. All right, good morning. Today I'm going to be doing a lesson on areas of parallelograms, triangles, trapezoids, and rhombuses. And we probably should include the word kites in there, because we are going to do kites also. Pretty easy assignment. Not a lot of stuff here that you have to know that's not pretty common sense. It will a few times it's going to make you go back and think about 30, 60, 90 triangles or 45, 45, 90 triangles, maybe even some Pythagorean theorem in it. But the first one we want to talk about is the parallelogram, okay? So if I have a parallelogram, the formula for the area of a parallelogram is base times height, which looks like a rectangle formula, and in fact it is, okay? Here's what you do. What you do is you cut it like right here, right? So you cut that piece off, and then you move it over here, like this. Now watch. The original base was this, right? This blue line. And now the base is this yellow line. Well, they're the same length. So in a sense, what you're really doing is you're finding the area of this rectangle, right? So this rectangle right here is the same as the parallelogram. So the formula is just base times height. And remember, the height is always measured straight down, right? That's the height right there. And that's the base, and this would be the same base, yeah? So base times height, pretty simple, nothing hard there. All right, so the next one, well, let's just do these three examples real quick first, and then we'll go to the next section. All right, we're going to find perimeters and areas of these three parallelograms. We're actually just going to do the first two. All right, let's do the area first. So area is going to be base times height, right? Well, the base is this distance right here, right? So 18. And the height is this distance right here, because remember, you're just going to magically move it over here, right? Slide that over here, and then it becomes a rectangle. So 18 times 16. 18 times 16 is 288. 288 feet squared, yeah? All right, perimeter. Perimeter is going to be the distance around the shape, right? Well, I already know this, the top is 18. I know the bottom is 18. What I don't know is these two red sides. I don't know this side and I don't know this side, right? So let me clear this up a little bit. We have a right triangle here, and that's how we're going to find it, right? We're going to call this x. We can find out what that side is because 8 squared plus 16 squared equals x squared, right? Or the square root of 8 squared plus 16 squared equals x. I don't mind if you use a calculator on this, just show me your work, okay? So, however you want to do it is fine with me. I kind of feel like, does a standard calculator have a square root? Yay, it does. All right, so 8 squared plus 16 squared equals, let's try that again, 8 squared plus 16 squared equals that, and then take the square root of that, so 17.9. So this is around 17.9, which makes this around 17.9. So double that, right? Plus the two bases, which was what, 18, plus another 18, plus, what is that, 35.8? Holy cow, 36 plus 35.8, 107.8. Check my math for me, somebody. 107.8 feet. All right, and all I did was just added up the four sides. Pretty easy stuff. All right, next one. Now be careful here. This is a 60-degree angle, and these are all equal, right? So in a sense, it's kind of like a rhombus, but we're going to do it as a parallelogram. Oh, actually, Yeah, it is a rhombus, but this is going to work, right? These are all 24. Okay, so let's do the perimeter then, because that's easy. It's just going to be 24 times 4, which is 96, I believe, right? 96 inches. Area. All right, this is harder, because if this is 60, then this is 60, right? Which makes this a 30, 60, 90 triangle. So I'm going to blow it up, but not that big. All right, so let's look at this 30, 60, 90 triangle real quick. 30, 60, 90. Remember the 30, 60, 90. This is x, this is 2x, and this is x root 3, right? So this is 24. So that would make this 12, and that would make this 12 root 3, right? Okay, so this is 12 root 3. All right, so I have enough information now to get the area, because the area is base times height. The base is 24, and the height is 12 root 3. I'm not going to go into why that's 12 root 3. If you're struggling with 30, 60, 90 triangles, go find your notes or the video on the 30, 60, 90 triangles, okay? All right, so we get 24 times 12. Oh, good Lord. 24 times 12 times 3 rooted equals. Nice. That sounds reasonable. 24 times 12 times 3 rooted is 499. 499. Actually, 498.8. Inches squared. All right. Any questions so far? This is a good time to pause and answer any questions. Anyone? All right. So parallelograms is just base times height. Okay. Not a big deal. I'm not even going to do the square. Okay. This square here, you know, you would just multiply this times this to get the area, and then just add up the sides to get the perimeter. Waste of time, really. All right. The next one is the triangle. So let's go back, and I think earlier in the school year I did a good job with this, so this shouldn't be that hard. Remember, if I have a base, right, and I have a line up here, a line that's parallel to the base, and I construct a triangle with this, right? This is the height, the distance from that top straight down. That's the height. All right, so here's my question. If I went over here and I found the area of the blue triangle, what would I notice about those two triangles? Anyone want to speak up? What would I notice about those two triangles?
They'd have the same area?
They'd have the exact same area. I can even add this one, right? They all have the same area, and here's why. Because they all have the same height. The height for the blue one is here. The height for the green one is here. They all have the same base. They all have the same height, right? And since they all have the same base and height, they all have the same area. So it doesn't matter how I move that point, right? I can take this point and move it anywhere parallel to the base that at that distance, right? And it's going to be the same area. All right. Okay, so real easy. Let's do first things first. We need to figure out what this is, right? That's h. Ooh, 3, 4, 5. So h is 4. So this is 4. I also need to find this to find the perimeter, so I might as well just calculate that right now. I'm going to find that using Pythagorean theorem, right? So call that x, right? X is going to equal the square root of 15 squared plus 4 squared, right? So what do we get? We get 15 squared plus 4 squared, 241 square rooted, about 15.5. So this is about 15.5. All right. So let's do the area first. Area is equal to 4 times the base. Let's talk about this carefully. The base is how long this is, right? Not how long this is. I don't care about the 3. The 3 is there to help me to find the height, okay? All I care about is the base of the triangle, so 15. divided by 2 because remember, a triangle is just half. A triangle is just half of a rectangle, right? So divide by 2. So what is that? 30? 30 centimeters squared, right? Perimeter is going to go around the shape. So from there to there to there to there, right? So what is it? 15.5 plus 4 plus 15 plus 4 plus 15. I don't mind if you use a calculator to do the math today, but you got to show me the work. All right, next one. All right, somebody speak up. Where is the height of this triangle on letter B? Anyone know where the height of this triangle is?
It's all the way to the left.
Yeah, so it's this number right here, right? It's the distance from the top straight down. Good, so the base is 22, the height is 16, and we divide by 2 because it's half of a rectangle, right? So I'd make that 11. 11 times 16 is 176. So the area is 176. The perimeter, I need to figure out what this is, right? I don't know what this is. Well, it's a Pythagorean theorem, right? So x is equal to the square root of 16 squared plus 8 squared. Why do I feel like I did that number earlier? Didn't I do that number earlier? Oh yeah, I did, 17.9. I don't know why I didn't catch that. All right, so this is 17.9 using Pythagorean theorem, right? Okay, so the perimeter is going to be 16 plus 22 plus 17.9. So 17.9 plus, what did we say, 16 and 22? 55.9. All right. All right, letter C, same thing, right? That's the base. The base is 40, the height is 11. You can find the area and then use Pythagorean theorem to figure out what that is and just find the perimeter. Any questions so far? Go ahead.
Mr. Bussy, on B, did you do the perimeter right? Because you added 16 instead of 34.
Oh, yeah, you're right. Good catch. Thank you. Yeah, this 16 should have been a 34, right? So what's that going to change it to? Let's do it again. Thank you for catching that. 34, 22, and 17.9. 73.9. Does that sound more reasonable?
Yes.
All right, trapezoids. Let's look at a picture real quick. All right, go back in time. Remember this thing we did with trapezoids where we did mid-segment, okay? Mid-segment we're going to use for in a minute here. All right, so this is base 1 and this is base 2. And it doesn't matter how I draw the trapezoid. I can draw the trapezoid like this. And it does the same thing, okay? This is base 1, this is base 2. Okay, so the way you do this is you find the mid-segment. And the mid-segment is that distance from here to here, right? And this distance ends up being the average of the bases, right? You take the two bases and you take their average and you make the mid-segment. Now watch what the mid-segment does. Let me do it in a different color. What the mid-segment does is it gives you a point that if you draw it right there, right? If you draw in the line to the mid-segment, you get a rectangle, right? You get this rectangle right here. Hopefully you can see this. And that rectangle has the same area as a trapezoid because this, let me change, I don't like it. Yellow's not gonna work here. All right, and this trapezoid has the same area because this triangle ends up going in there and this triangle ends up going in there. Same thing over here, right? If I create the mid-segment, right? And I draw it in here, this piece ends up going in here. Yeah? So all I have to do is find the mid-segment, and the way you find the mid-segment is you take the average of the bases, and then you just multiply it by the height. Yeah, because you're just I call it morphing it into a rectangle, right? So I'm turning it into a rectangle. Does that make sense, everyone? What I'm doing? Yes, no?
Yes.
All right. So,
Yes.
so example A, I would find the midsegment, right? And I find that to find the area, we're not doing perimeter here. To find the area, I would just find the midsegment. So I would do 18 plus 15, I'm sorry, 8 plus 15 over 2 times the height. The height is this distance, right, which is 5. And that's it. So let's do that. 8 plus 15 divided by 2 is 11.5 times 5 is 57.5. So 57.5 inches squared because it's an area. All right. All right, next problem. Find the midsegment, right? The midsegment, the area is going to be the midsegment, which is 30 plus 18 over 2, times the height. The height is 16. So what's that? 15 plus 9 is 24. I think this is 24. Check my math. 24 times 16. 384. 384 feet squared. All right, so that's trapezoids. Pretty easy. Now we're going to get into the last two, which is the rhombus and the kite. All right, so sometimes when they give you a rhombus, right, where these are all equal, what they do is they tell you what the diagonals are. So this is diagonal 1, right? And it doesn't matter which one's diagonal 1 and which one's diagonal 2. This green line is diagonal 2. And then if you play with the math for a while, you realize, remember, these bisect each other, right? And they make right angles here. This is equal to this. This is equal to this. So you get this, this shape every single time. And what you end up doing if you play with the algebra for a little bit, you end up getting diagonal 1 times diagonal 2 divided by 2 gives you the area. And in fact, what you end up doing is, I don't know if you can see this, but what you end up doing is you put the two triangles like this triangle and this triangle. And then you start realizing that it's the same as this triangle, right? Because this piece can go in there and that piece can go in there. And you end up making this triangle. And then in fact, when you sketch this out, this ends up being this. I'm not going to go into the math of it. It's a slightly annoying one to do, but that's what you're doing, right? You're morphing it into a triangle, okay? And all you do is do diagonal 1 times diagonal 2 divided by 2. If you have a kite, the cool thing about a kite is that the same formula works, right? This is diagonal 1. This is diagonal 2. And you just do d1 times d2 over 2. Pretty easy. And sometimes they're going to hide a Pythagorean theorem in here. You'll see in a few minutes. All right. Example A. So find the area of this rhombus or kite. Well, so this is 20 and this is also 20. This is 26 and this is 56, right? So remember, area is equal to diagonal 1 times diagonal 2 divided by 2. So diagonal 1 I'll do in blue, right? Diagonal 1 is this diagonal, which is 56 plus 26, right? So what is 56 and 26? 70, 82? 82 times diagonal 2 is this darker blue line, right? That's 40. And divide by 2 because it's going to end up being a triangle. So 82 times 20 is 2 of that 164 with the 0. So 1640. Someone check my math for me, please. Does that look good? Well, since someone's speaking up, I guess that's right. But that's all you do. Diagonal 1 times diagonal 2 divided by 2. All right, next problem. Remember, diagonal 1, which is 20, right? So the area... Go ahead.
I think it's double that, because you multiplied it by 20. You're supposed to multiply it by 40.
I did. But then I divided by 2 because the formula says divide by 2. So what I did is I divided 40 by 2 right here.
Okay, that makes sense.
Okay. Thanks for asking. All right, so diagonal 1 is this distance in blue, which is 20. Diagonal 2 in red is this one right here. And that's 40. And then we're going to divide by 2 because it's a triangle. Knock off those, make that 20, right? So that's 400. So 400 centimeters squared. These are really easy to do. So, all right, next problem. If this is 8, then this is also 8, right? And if that's 7, that's 7. All right, so the area is going to be diagonal 1 times diagonal 2 over 2. So we're going to get 14 times 16 over 2. I'm going kind of fast here because they're so easy. Make that 8, so 14 times 8, 2, 3, 8, 9, 10, 11, 112? 112 meters squared. All right, any questions there? It's a good place to pause before we get to the last 3. Okay, and just incidentally, sometimes they'll give you like this side link. They'll tell you what this is, and they won't tell you what this is, but you can use Pythagorean theorem to figure out what that triangle is. So sometimes they'll hide it from you, so just be ready for that, okay? All right, last set of problems. We want to find we know the area, and we want to figure out what the height is, right? Well, the first thing you should do is just write the formula. So diagonal 1 plus, average of the bases times the height, right? Mid-segment times the height. What do we know? We know the area. So 164 equals base 1, 12.8, plus base 2, 20, divided by 2 to find the mid-segment, times the height. All right, well, we just do the math, right? So 12.8 plus, was that 20? Equals, divided by 2, 16.4. So we get 164 equals 16.4 times h. Divide both sides by 16.4, and you get 10. H is 10. That's it. Pretty easy. Just do the algebra, let the algebra prove it to you. All right, second one. Well, this is a rhombus, so diagonal 1 times diagonal 2 divided by 2. I know the area, so 340 equals diagonal 1 is this distance, so that's 20. Diagonal 2 is this. If this is x, then this is also x. So this is 2x. Divide by 2 because it's a triangle, right? Knock off the 2's. You're left with 340 equals 20x. Divide by 20, x is 17. Any questions there? Okay, last problem. So we know kites use the same formula, diagonal 1, diagonal 2 divided by 2. Area is 247.5. Diagonal 1 is 22.5. Diagonal 2 is x this time, right? Because they say this is x. So divide by 2. In this case, I would actually double both sides. So I would do 247.5 times 2, double both sides. So this is 495 equals 28.5x. And I think when you divide that by 28.5, you get 22. Did I do that right? I could have sworn it came out pretty earlier. Divided by, what is that number? Oh, 28.5, that's why. Oh, that's funny, because Gillespie can't read his own writing. 22.5. Let's try it again. 495 divided by 22.5 is 22. I thought so. All right, there you have it, okay? Just remember, areas of parallelograms is base times height. Area of triangles is base times height divided by 2. Trapezoids is mid-segment, right? I'd rather just do base 1 plus base 2 divided by 2 times height, right? Mid-segment times height. And then you got the rhombuses and kites, which is diagonal 1 times diagonal 2 divided by 2. All right? So hopefully that's enough to help you out. I'm going to stop this video and then answer some questions.